And welcome back, ladies and gentlemen. This is Kosmographia Live. We are the Randall Carlson podcast. And it has been a while since we've done a live stream or a recorded show. Everyone has been busy. Kyle and I especially. We've been in the midst of harvest here in Texas. 33 tons of grapes we harvested, just about. Processed, and so we've been working hard for the past month. And well, Kyle's really been working hard. I've been pretending to work hard, trying to give the impression that I'm doing lots of complicated stuff, but Kyle's definitely been working hard. Go ahead.
Well, that kind of reminds me of the parable of Cain and Abel, because you remember Abel was a shepherd, so all he had to do was sit there and lay under the tree all day and kind of keep an eye on the flock. Poor Abel, he was the farmer, so he was having to dig and plow in the ground and all of that. So poor Abel is just struggling there to plow the ground up and plant his crops, and Abel is just sitting under a tree. And
Cain was the farmer and Abel was is that what you're saying? Cain was the farmer? Yeah.
And that's what led to the problem. There was something we'll have to talk about.
Are we going to have a problem, bro?
Well, it was the older brother that killed. It was the older brother that killed the younger brother.
Yeah, I know.
So,
I'm too.
Kyle, I don't know, man. I'd watch your back if I were you after this.
Wait a minute.
From what I just heard. I'm just going by what I heard.
I'm too OCD for him to take charge. It's like, wait, it's got to be done this other way.
No, Kyle is the boss at our day job. Like, he's definitely the boss. I'm just the boss everywhere else. So it works out great.
That's a good system.
Yeah, it's
know that role. So how many gallons is that? 33 freaking tons.
About 4,000 gallons.
Don't you have a gallon count? Yeah. Holy crap.
Yeah, when we pressed it, we got a little bit better count.
Yeah.
So yeah, we're gonna have about 4,000 gallons this year.
60 all the same or multi different?
No, different
varieties.
Reds, whites, rosé. So
right.
we got many different varieties of grapes. Cabernet Sauvignon, Merlot, Tannat.
So that's almost 70 barrels.
Trebbiano.
Creek Vineyards.
Yeah. That's almost 70 barrels of wine. 67, 68 barrels. Now, of course, the white and the rosé are not in barrel. They're in tank. But if we were to put it all in barrels, it would be 67 or 68 barrels of wine. That's a lot.
59 gallons apiece.
Yeah.
Take a big truck.
Yeah.
Yeah, it's gonna be about 21 to 2,500 cases.
That's impressive.
Wow. Guys, we're working, or at least one of you.
Yeah.
No, we were. I mean,
I was working until I got sick. So
work yourself into sickness.
Yeah,
exactly.
I got ill the second,
for the finale.
We had just basically finished the crushing, so all the harvesting, and then we bring it, and then we process the grapes, which is like destemming and crushing them. And we had just finished that process when I started to get sick. So
what you got sick of harvesting, or
I got sick of Kyle. Yeah.
Okay.
No. No, I had a fever, and then I was like, dude, if I keep coming to work, even if I feel good during the day, and then you get it, then we're really going to be screwed.
Stay away.
Yeah,
I was like, I can't get sick. And then I ended up getting it like right at the end.
Right at the end anyway, yeah.
So what was it?
I don't know. I didn't go get tested or anything. It was just like it was like a bad cold. I ended up with a cough. I had a fever one night, so I'm good. I'm good now. But now Kyle's coming off the back end of it. So
I think it's syphilis.
Okay. Well, I won't make any comment on that. Yes,
I'm not going to comment either.
Wait, are you saying I gave you syphilis?
Nope. I think that's what you had.
So you guys have pretty much got that behind you now. Do I understand that correctly?
Yeah.
Well, there's a little more to do. I mean, we're still barreling down, so we've got we're about to bottle.
Yeah.
2022 wines. So I've got 400 cases to bottle, and still another almost 1,800 gallons to put in barrel. One particular batch of the wine, one lot, was 1,600 gallons by itself. So that one hasn't been barreled down yet. So yeah, it's just it's just not 70 to 80 hour weeks at this point. It's calmed down quite a bit, but it's been like that since the beginning of August, pretty much. So this was the first weekend I actually had off since.
So we get to blame not having a show because of you guys.
That's right. Yeah, for the
All
past
right,
4 weeks, it's been us.
It's been
for
my
sure.
fault.
Yeah,
our fault. But I mean, this is kind of the way harvest is going to be
from now on.
Going forward, because we've got
Yeah.
this 11 acres
And
of
if you
vineyard
get bigger,
Yeah.
coming on. It's maturing, and it's going to be even more next year.
Yeah.
So once we have it,
this is be a yearly thing, though. Right? Is that pretty much still this time every year for the rest of your lives? You'll be having to go out there and sweat in those fields.
when the moon tells them so.
well, we're actually in the
It'll be
winery
that
mostly.
time.
Yeah, we're getting up before daylight and going and loading the bins, because the harvest crew was harvesting all night. So we'd load all the bins on the trailer early in the morning before sunrise, before the temperature got up, and we'd drive them to the winery facility and process the grapes and get the vats inside the winery and get them inoculated, get all the juice balanced, pH and acid, and then inoculate with the yeast. And then fermentation, and you're doing this every day. So then I'd take all the harvest bins back and put them back in the field at night, and then I'd go to bed, get up in the morning, load them all back up. They're all full again, go back to the winery. And we were doing this for 6 or 7 days. And then by the end of that, they're all fermenting, and now you're at the winery every day, and you're having to deal with these fermentations, trying to keep them cool. And it's just nonstop and long 14-hour days, day after day, no weekends, no days off.
I'm getting tired out just listening to it and thinking about it. I'm glad you guys are doing that, not me.
Yeah, so that's pretty much August. I mean, that's why we try to stay away from booking tours and things and stuff like that in August.
Oh, okay. Well, at the end of today, we'll talk about we got some pretty cool tours coming up, and I want to talk about those at the end.
Always
Been
cool
some
tours coming up.
new explorations and stuff. The Mid Cumberland tour is taking shape nicely. We've got some places off the beaten path that are kind of exclusive.
That one's going to be over Halloween, so that'll be fun. Gonna have a party for that, and definitely some sky viewing and potential crossers of the sky in one way or another.
And then, of course, for the participants of the tour and the staff, we will all be in costume for the, so.
You got to go as Gandalf?
Who, me?
Yeah, you should go as Gandalf.
That makes it easy on him.
Yeah. Just get a robe. You're fine.
No, I'm thinking I'll go as a badger. I'm going to get out and dust off my old badger costume I've got. So,
honey badger. So the Minnesota's a gophers up there, not the.
Yeah, but there's badgers up there. No, I don't think we have any badgers in Tennessee. Do we? I don't know.
No idea.
So what's the meanest pound for pound?
Wolverines, right? In Michigan, we got Wolverines.
You
so
just I was just about to ask, what's the meanest, toughest, baddest animal pound for pound in North America?
There you go.
Brad was anticipating what I was going to say next. The Wolverine. Nobody messes with Wolverines.
True.
So, anyhow, gosh, there's been a lot going on since we've been Been busy. Brad and I have both been on the road a lot. I've been to Colorado, New Mexico, North Carolina, Georgia, of course, where I live, and mostly those two places. But yeah. So we did
taking a summer off of traveling. I was so full on the road, setting up new tours this spring, and we're going to do more of that the next 2 months. But yeah, this summer I've actually been home, catching up with editing, getting some new content out for people, and catching up with the older podcasts. So we're up to 99. So number 100 coming soon.
Number 99, huh? Yeah, I know you've been out exploring some pretty awesome places, haven't you?
Very grateful. Very awesome places. Yep.
Yeah.
May that continue.
And charting them out, mapping them out.
Yep. So that's one of the tours we want to talk about later.
Yep.
The spring travels I did. We got a new tour, the third part of the Cordilleran Ice Age Mega Flood series.
That's coming up quick.
Gushing through the gorge with the Columbia River. So yeah, we'll talk about that one later.
So, yeah, some things that have been going on in the news this summer. There's been some weather events, and I thought we'd talk about a couple of those, perhaps.
Yeah.
What happened in Maui is probably worth consideration, especially in the light of, I don't remember what numbers those episodes were where we were talking about the catastrophic fires, Peshtigo, Hinckley.
Yes, the late 70s, early 80s, right around there. 78, 82. I was looking the other day because somebody was inquiring about the Maui fires and the comparison. So yeah, go ahead. Yeah.
Well, yeah. So there were some
I'll
comparisons.
link those in the description.
And I did note something. Now, whether it's of any significance, I'm not going to claim it's of any significance because it could be merely a temporal coincidence. But the fires did break out over the 8th to the 12th, just as we're heading into the peak of the Perseid meteor shower. Now, we made circumstantial case that there may have been a cosmic component to some of the, particularly and especially the Peshtigo fire, the Chicago fire, Manistee fire in Michigan, all breaking out simultaneously as if they were all ignited by the throwing of a single switch, right? And we did show that there were some rather interesting atmospheric anomalies going on and possibly even evidence of a major meteor shower, because many of the eyewitnesses described seeing things that reminded them of fireballs and plumes of fire coming out of the sky rather than from the ground or from laterally from adjacent trees. If you remember some of the structures like the barns and the treetops, they described over and over again that the fire didn't seem to move laterally as much as it came down vertically. So like in the barns, it was the ridge beams of the barns and the roofs that caught fire first. Now, of course, that could be from burning embers coming down, and was undoubtedly that was a factor as well. But the eyewitness accounts that seem to suggest things like fireballs and the fact that it was right at the peak of the Draconid shower certainly was suggestive to me. Now, was such a component play a role in Maui? I don't know. But I did note that the Perseid meteor shower, which is famous for fireballs, by the way, and sometimes can have peak years. Now, the Perseids are part of the disintegrating comet Swift-Tuttle. So in order for me to have any kind of thoughts on if there was a component, I would have to look into more. Where was Swift-Tuttle in its orbit during that last week there, from the 8th to the 12th? I don't know. I haven't been able to have a chance yet to look that up. But that's where the Perseid meteor shower comes from that comet, Swift-Tuttle. I don't know, Kyle, if you want to pull anything up on Swift-Tuttle that might be of relevance here.
I can look.
You looked like you were available for such a task. So, yeah, some other interesting things. Let's see. studies that have come out about the natural variability of climate, linking the variability of climate to solar changes. So that's ongoing. The role of the sun is appearing to be more and more prominent in any kind of discussion about climate change, whether things are heating off or cooling. In fact,
so, I mean, I got a synopsis here, but what are you wanting to know in particular about it?
Well, I was mostly, I guess I was wondering where it might have been in its orbit. What's its orbital period?
133 years, and last perihelion was in 1992, and it will return again in 2125.
Okay, so it's out there. It's not. So it's probably just a coincidence.
But it is the source of the Perseid meteor shower, which takes place every August and peaks mid-month. We're watching that.
Well, I was wondering about the idea of, an accumulation of flammable substances like methane or ethane that do seem to be a component of the Hinckley fires and the Peshtigo fires, if you recall.
Yes.
The Chicago fires. In the day or two leading up to the Chicago fire, people were like not going down into their basements and stuff because there seemed to be so much gas accumulating. And they would report smells that smelled like gas, and people were having headaches and stuff. So again, that doesn't prove anything, but it's an element that can build a circumstantial case. So
aren't some of the asteroid tracking stations there in Hawaii?
Yes.
So yeah, you just wonder if they've got cameras that are on all the time. I know they do in some places.
So as one could expect, and as soon as I heard about the fires, I knew what was coming next. That totally the fault of you guys driving your SUVs. So I have a quote here by James Steele, who's a botanist and been studying some of the foliage particularly in Maui. And writing for the CO2 Coalition, I'm going to quote from him now. The Maui fire would have devastated, now am I saying this right? Lahaina?
I think it's
the
Lahaina.
Town, Lahaina, that got pretty much erased.
Yeah.
If you've seen the pictures, maybe, Kyle, you might even pull up some pictures of Lahaina, and we can see how severe the devastation is. Can you do that?
Brad will have to do that.
Yeah.
I'm doing it.
It's charred bad.
Yeah, okay.
I can't
So
share
the Maui-
screen while streaming.
I got you. The Maui fire would have devastated Lahaina in a colder or warmer climate. It would have devastated Lahaina in high or low CO2 concentrations. The key is managing the dead grasses that become flammable in just hours. And I know that for a fact from my own experience, because I think it was summer of 1965, perhaps. I was probably 14. Me and Rowan and one of our buddies, Hank, were out playing. I don't know what we were playing. It was spring. It was spring in Minnesota. And, there's this long grass, probably not unlike the grass that's being referenced in this quote from the botanist here. And then, of course, the snow melts away. And if you have a fairly dry spring, you'll have huge masses of this dead grass that's about 3 feet long, typically. And it covers the areas of the fields and stuff that haven't been grazed over for a few years. So there was this area of about 40 or 50 acres to our immediate south from where we lived there in rural Minnesota. And we were out playing this spring, and it had been a dry spring. And it was kind of windy, and I think we were playing War, which I don't know, did you guys ever play War when you were at that age, 12, 13, 14? Yeah,
definitely.
I mean, so we were playing War, and I don't remember, I guess we were soldiers in World War II fighting Nazis, I think, on that particular day. But the fellow we were with, he was gonna create some kind of subterfuge or something. So I don't know what he was thinking, but he lit this fire. And right after he lit it, a gust of wind came.
Oh,
and
no.
and so, yeah, it turned into a conflagration. And the first, me and Rowan and my other brother Rocky saw that, and we took off running. And then we all got maybe 50 yards away, and then we looked at each other, and no, we can't leave our pal Hank back there. He's back there hollering, and he's trying to beat the fire out with his coat. So we all run back, and I would say the next 45 minutes perhaps was a futile attempt to suppress the fires. And I mean, the wind had picked up. There was a swamp right there next to where this hill was that was on fire. And we'd run down there and soak our coats in the swamp and then come running back up and beat, and we'd just about get it. And then a gust would come along. And I mean, we're talking there were flames 10 and 12 feet high. And then finally it got away from us, and we heard some distant sirens. So we took off, and fire trucks came out there, and we're able to put the thing out. But not until it had burned up about 50 acres.
So you're saying that Nazis set your backyard on fire, Randall? Is that what you're telling me?
No, actually, one of my brothers in arms was trying to fool the Nazis.
Oh, no.
I don't know why. We never did get straight exactly what his tactic was, but it backfired big time. But the thing I remember is how quickly that grass caught fire and spread. I mean, it was just like was described, like James Steele was describing. It was like instantaneous. And yeah, so by the time we ran off, I mean, we were completely, covered. We'd been into smoke, and our faces were covered in, black, and yeah, it was a mess. But anyhow, it was very exciting. And
nope, we didn't see no fire. It's just like covered.
Well, actually, I did one of the I don't know if he was local county fire marshal or who he was. I just remember he looked official. He came up, he was pulling up the gravel road there just as we're heading away. And he stops, and I tell him that I saw some boys running off. I pointed down the road. I said, they ran off. We saw them. We came over here to try to put the fire out, and we saw these boys running away so I guess now I'm going to get turned in. The next thing I know, Plymouth County is going to be calling me, showing up at my door. So that was you guys. I'll be charged with arson.
I think the statute of limitations is up on that one. You probably okay.
Yeah. I think it was in spring of 1965.
Oh well, they might still come after you then.
Yeah, that's what I'm saying. It was the 20th century, right? Okay. So, anyways, my whole point of this is that I just remember so well. I have a very striking memory of how quickly that fire got out of hand when the wind would gust. And I mean, it was impressive. So this is what James Steele, here's his point. The key is managing the dead grasses that become flammable in just hours, because this was now you remember, I've looked into what the situation was. To the north was a high pressure zone, and to the south, remember, there was a typhoon, a hurricane. To the south, it created this low pressure zone. So that pressure differential caused a major downslope wind, a really intense downslope wind, to form on the west side of Maui, which was steep mountains pretty much from the peaks, from the crests of the mountains right down to the coast. So you had this really strong downslope wind, and that combined with the really dried grasses, because here's what happened. That downslope wind was gusting at 60, even up to 70 and 80 miles an hour. So it downed the power lines. The power lines fell into this dead grass that's 4, 5, 6 feet thick, that is a non-native invasive species, covered thousands and thousands of acres of Maui, along with some of the other islands. Those power lines went down into that grass, sparked, and instantly set these things on fire. Now, the real problem was there was very minimal, if any at all, preparation. There were warning sirens and stuff that didn't get turned on until it was too late. James Steele, this is what he says again. The key is managing the dead grasses that become flammable in just hours. Climate change was irrelevant. Declaring a climate emergency to reduce fossil fuels is a useless remedy that only misdirects funds that will be needed to better manage a fire-prone landscape. And this was an extremely fire-prone landscape. That needs to be emphasized here. So here's the LA Times ran this headline on August 11th. If the Maui fires don't wake up Americans to the climate emergency, nothing will. Now, 5 days goes by, same paper, and here's the headline, that they could not avoid running, okay? And I quote, ignored warnings, hubris, slow response fueled America's deadliest wildfire in a century. Followed by this. Maui County, that was end of quote. Now it was followed by Maui County officials knew the fire risks, documents show. Despite hazard plans and reports, it appears that little was done to prepare. So it should become apparent to anybody who's objectively looking at this that, of course, these officials who had dropped the ball, who were incompetent, of course they're going to blame climate change, global warming. It just goes without question. You knew that was coming. But what it really came down to was the fact that these grasses had not been managed. So basically there was a lot of agriculture, grazing animals and stuff on this side of Maui that ceased a number of decades ago, and then these invasive grass species just took over. So what were the known fire risks that were ignored by county officials? And one of those risks was the regional weather pattern at that time with the high and the low pressure systems that caused the downslope winds, which are normal every time, at this time of year, but made them so much stronger than normal. This was strictly a weather thing, and you cannot blame the high pressure system to the north or the low pressure system to the south on anything but natural weather. Okay, there was nothing unprecedented about those two weather atmospheric conditions. The fires were most severe along the western flanks of the West Maui Mountains, and that's where these winds were. So it was a stronger than normal high pressure system centered just north of Hawaii. So then that engendered very powerful southward directed trade winds. There was a zone of stable air at or very near the crest of the mountains. So without going into detail on the meteorological specifics, it is enough to explain that the wind sweeping south ran up against the mountains, capped by, if you can picture this, so you've got this really stable air mass. Here's the mountains. The winds first come sweeping up, and you've got this stable air mass here that causes the wind to loop around and then come back down the mountain. So this is what created these intense gusts, was this turbulence that was introduced into the rising air. And there's a name they actually have a name for that phenomenon. It's called a mountain wave. A mountain wave is when the air does that 180, it loops around like this and then begins to flow back down to a lower elevation. So then that wind, even if it's rained, earlier in that day, that wind is so dry that it will evaporate and completely dry out the grasses within an hour or two. So that's one of the things that led to the intensity of this whole phenomenon. But ultimately, you had natural conditions confluing that created the intense fire. You had artificial conditions, which you could start by blaming the presence of all of this grass and the highly flammable grass. And then you had the incompetence and slow response time of government officials. So you had, despite the fact of a rainier than usual winter, which caused, that's another factor. The rainier than usual winter caused really prolific growth of the grasses. So the grasses were now up to probably in some cases 6 and 8 feet high. So it was these predictable circumstances that were ignored by incompetent government officials. So the other thing was, we've heard all summer about the hottest days on record, and we have had some hot days for sure. Maybe we should talk about that for a minute. Because one of the things that got ignored in the mainstream press was the eruption of the submarine volcano. You guys remember that? What was the name of it?
I can't remember. This was a while back though, right?
Yeah. Oh yeah.
Amazing
Sent a
satellite
shockwave
video
across
of it.
Yeah.
Look at it. Somebody in the
so
chats probably knows what we're talking about.
Oh yeah. So
Hey,
hottest
you guys
days
get
on
Randall
record.
full screen some of the time. I was trying to send you a message.
Oh, I should be doing that.
Yeah, we can do that. Yep.
I forgot how to do that. Command shift something.
Just making a speaker view probably.
So here was the headlines from July, some of them from Washington Post. This July 4th was hot. Earth's hottest day on record, in fact. Then you had a website, Sustainable Future, says, we are in uncharted territory. World records hottest day ever. Ever. The hottest day ever, Russ.
Ever. Yeah.
Tonga was the volcano, the undersea volcano.
Tonga,
right?
there we go, yeah.
Near Tonga.
And then CNN says, CNN, that bastion of truth and unbiased reporting. They ran this headline: the planet saw its hottest day on record this week. Of course, now bear in mind that the record started in 1978. Okay. And we'll come back to that in a second here. And then they say it is a record that will be broken again and again. United Nations, I got a quote here, United Nations Secretary General Antonio Guterres said the era of global warming has ended. The era of global boiling has arrived.
Yeah, I did hear that.
Yeah, this is it. We're in it now. The era of global boiling. So,
And we're the frog that's not supposed to notice until it's too hot and we die.
yeah. So then this was from the magazine Mother Jones. It said that Earth's average temperature hit an unofficial record high on Tuesday, according to, and this is where everybody's drawing their information from. Okay, they're all pulling from the same source. Unofficial record high on Tuesday, according to the University of Maine's climate data website, Climate Reanalyzer. It wasn't a fluke. The temperature hit the same reading on Wednesday. So clearly, if we take all this rhetoric at face value, we have to conclude that we're doomed. No question. We're doomed. So you guys might as well forget about the winery. We're doomed. It's going to be too hot to grow grapes. So
I've been hearing a bunch of that in the wine industry. People, they're just like, oh, global warming. We're all,
all the vineyards are doomed.
Yeah.
Yep, that's what I'm talking about. First of all, let's get down to a few facts here. There's two types of records that we could be referring to. One of them would be a thermometer-based record, where you actually have thermometers out there and you record the heat off those thermometers. And actually, the thermometer base, I said that 78. I was wrong. It was 1979 that those records go back to, right? So we're not talking about going back into the Pleistocene or anything like that, or into the Pliocene, the hottest day ever, okay? So these records, you've got the thermometer-based, okay, and then the other one is the proxy-based. And you understand about proxy-based. We've talked about that on the show. You know, that's where we use something else, which could be oxygen isotopes in Greenland ice cores. It could be tree rings in a dendrochronological analysis. It could be the types of pollen and seeds that you find associated with a particular soil type. It could be looking at sediments from ponds and lake bottoms. That is a proxy for what's going on in the weather. If you've got dry years, your sediments are going to be sparse. If you've got wet years or floods, your sediments in the pond or lake bottoms are going to be much thicker, greater amplitude. So these are what we mean by the proxies. So proxy records and thermometer-based records. Got it? Those are the two by which we'll reconstruct past climate, past weather, past temperatures. Okay. Now, here's the thing that they conveniently left off. Now, you guys aren't old enough to remember. I'm old enough to remember very well the fears, and we've talked about this, and this is, you know, one of the criticisms that the conservative side of the spectrum will frequently bring forward is that in the 1970s, the big fear was the return of an ice age. You guys are kind of remember some of that, or at least know that
We're
that
aware
was,
of it, yeah.
You're aware of it,
Yeah.
right. Okay, so that was the result of two things. One was the fact that we now knew from accumulating radiocarbon records that ice ages had come and gone a lot faster and more frequently than we'd previously imagined, and that the interglacial periods typically looked like they were no longer than the Holocene. Okay, so you had that data. Then on the other hand, there actually was a global cooling over a period of about 2.5 to 3 decades. It came on the heels of that early 20th century warm period that got to its worst and peaked out in the mid-1930s during the Dust Bowl, when over half of the all-time high temperature records of the states in America were broken and set and still remain unbroken from those 1930s. Now we get to the 1940s and the planet began to cool. And so for the next 25 years or so, the planet was actually cooling. And so this was the other factor, that you had the realization that ice ages came and went a lot faster, that interglacial ages were much shorter than had been imagined. And now we were in a period of global cooling. So that actually provided a somewhat justified basis for some concern. Now, of course, the media took that, ran with it, exaggerated it, and now it's serves as fodder for criticism, say coming from the right wing, which says that that was completely unfounded fears. Well, not really. There were some legitimate cause for concern. Okay. Anyways, now that comes to an end. When did it come to an end? The late 70s. And by the time you get into 80, 81, 82, the climate, and maybe I can even on a break pull up a graph, and you can see it. You can see the graph of temperature climbing up until the 1940s, up until about World War II, and then it actually starts cooling off again, and then come in the early 80s, it starts climbing up again. Then it levels off pretty much into the 21st century. We can see all of that in the graph. But here's the point. If you take and you start, your record goes back to 1979, but 1979 is coming right at the end of a cool spell, a 30-year cool spell, and the beginning of a 25, 30-year warming, well, of course, any temperature data that comes after that is going to be setting records, isn't it? Now, those records that have been set subsequent to the late 1970s have not been enough, say, at least in the Western Hemisphere, to break the heat records of the 1930s. Okay, so that's the first factor that you have to keep in mind, is you have to have this larger scale perspective on on the temperature data. Okay, so that's important. So most of the records in question go back to 1979. Other records that were used, so it wasn't exclusively temperature-based records from 1979, and it was post-1979 and into the 80s that we started getting satellite data as well. But then other records that were referred to in the mainstream media were going back to the early 20th and late 19th centuries. So you know what was happening there, okay? So you got this other body of data that goes back to the beginning of the 19th century, the beginning of the 20th or the end of the 19th century. And of course, what's happening then is we've established a second baseline, and that baseline is at the end of the Little Ice Age. So in the late 19th century, early 20th century is when this rapid warming began that led us up to the 1930s. So in both cases, the data used, the baseline, is coming at the end of a cooling period and the beginning of a warming period. And the analogy I've used is, let's say that, Russ, you're going to start keeping track of temperature data. So you start collecting temperature data every day, but you start this, and assuming we're in the Northern Hemisphere, you start this in early March. So every day, you're not going to have, there's going to be exceptions, but some days it'll get a little bit warmer and then cooler and then warmer and cooler, but the trend is going to be clearly upward, isn't it? As you go from March into April into May, and May into June. And now if you're keeping records, we get to June, we get to July. And if your baseline starts in early March, well, of course, you're going to be constantly breaking records, aren't you?
Yep.
Hottest day ever. Well, since your record keeping started. And then if you don't have, if your long-term memory is shot and you have no memory of what went on before March, if you don't have any memory of January or February or whatever, now you could be coming into June and July and going into a panic because the world is about to end because of global warming.
Yeah, the trend would be frightening if it was starting.
Yes, it would be.
Yeah.
But see, the whole key here is context. It's perspective. And that is what's conveniently being left out of so many of these discussions. And when you're talking about records, we're not talking about records of several degrees. We're talking about records that are measured in hundredths of a degree, right? And then here's the other question. Nowhere in there, in any of the accounts that I read in mainstream media about this or saw online or wherever, maybe half a dozen different accounts or more, because it's pretty much the same narrative, no matter what the mainstream source is. There's no reference to the role of the urban heat island effect, which is a proven effect, right? So now you have to add that on top of the fact of the natural cooling and warming cycles, and add in the fact that the thermometer-based temperature records are going to reflect the increase in temperature, because most of them are going to be either urban or even suburban. A smaller percentage are going to be rural. And now we'll save this for another episode. When we can really begin to look at in-depth detail the role of the urban heat island effect. We've already talked about that in episodes past, but it is a proven factor which can affect the thermometer-based record by a degree or more, or 2 degrees. And sometimes, even in the larger cities, the difference between the urban temperature and the rural temperature in the same latitude, in the same state, even the same county, might be as much as 5, 6, 7, 8 degrees. So the question that I raise when I see hottest day ever, okay, where is the data coming from? All right, the date, where is that data coming from? And we know where it's coming from, but it's coming from the Climate Reanalyzer in May. And let's see here. What can we say about that? The Climate Reanalyzer. Let's see here. Here's something. Well, let's see. The Climate Reanalyzer has been criticized for having crude and not precise records of temperature. I'll find a quote here that I had in discussing because that's what I was trying to get to, is the source of the data that was being used to fuel these headlines. And there was a source. It was the Climate Reanalyzer in May that they were all using. But then there's this other interesting thing here. So let's jump into that, and then I'll come back to this Climate Reanalyzer. In December 2021, and on into January 2022, and that was so end of 21, beginning of 22, there was a massive submarine volcano in the Tongan archipelago. On January 15th, the eruption reached its climax. It ranked VE-5 on the Volcanic Explosivity Index, which is extremely high. I mean, that's getting it up at levels of Krakatoa, okay? It displaced 10 cubic kilometers of rock, sediment, and ash, and it was the largest atmospheric explosion recorded by modern instrumentation. Okay. There were tsunamis as a result that affected Tonga, American Samoa, regions along the Pacific Rim, New Zealand, Japan, Chile, Peru, and even areas along the west coast of the United States. At the largest, the tsunamis generated by the eruption reached upwards of 66 feet in height. On the uninhabited island of Tofua, the wave run-up height reached 148 feet. And it's been the largest global eruption since Pinatubo which was in 1991. And it wasn't as, in terms of sheer power, it wasn't as powerful as the Krakatoa, but it was up there. So NASA judged that this eruption was at least 100 times more powerful than an atomic bomb. And in terms of its atmospheric disturbance, and this is where it assumes relevance, it generated a tremendous amount of atmospheric disturbance. So here is NASA's lead story from August 2nd, 2022. This is the headline: Tonga eruption blasted unprecedented amount of water vapor into the stratosphere. And here's quoting now from NASA, from their website. When the Tonga Hunga volcano erupted on January 15th, it sent a tsunami racing around the world and set off a sonic boom that circled the globe twice. The underwater eruption in the South Pacific Ocean also blasted an enormous plume of water vapor into Earth's stratosphere. And here's a quote from an atmospheric scientist at NASA's Jet Propulsion Laboratory in Southern California, Luis Milan. This is quoting him directly now from the story on the NASA site. We've never seen anything like it. So I might mention it. This guy, this atmospheric scientist, led the new study of the atmosphere, trying to determine the amount of water that the Tonga volcano injected into the stratosphere. The study was published in the Geophysical Research Letters, and they estimated, him and his colleagues, that the Tonga eruption sent around 146 teragrams, or 146 trillion grams of water vapor into Earth's atmosphere, which is equal to as much as 10% of the water vapor already present in the atmosphere. So it would have enriched the atmospheric concentration of water vapor by at least 10%. So that's nearly 4 times the amount of water vapor that scientists estimate that the 91 eruption of Mount Pinatubo eruption in the Philippines lofted into the stratosphere. So then the quote, then the report goes on back to from the NASA website. Milan analyzed data from the microwave limb sounder instrument on NASA's Aura satellite, which measures atmospheric gases, including water vapor and ozone. After the Tonga volcano erupted, the ML5, or micro limb sounder team, MLS, started seeing water vapor readings that were off the charts, quote unquote. We had to carefully inspect all the measurements in the plume to make sure they were trustworthy. The NASA report then goes on to say, the huge amount of water vapor hurled into the atmosphere, as detected by NASA's microwave limb sounder, could end up temporarily warming the Earth's surface. End of quote. So even NPR, National Public Radio, surprisingly, ran a story in August of 2022 with this headline: Tonga's volcano sent tons of water into the stratosphere that could warm the Earth. End of quote. So from more than a decade ago, MIT, as part of its joint program on the science and policy of global change, ran an article entitled, quote, Greenhouse Gases, Water Vapor, and You, which reported on a clarification from a previous post about NOAA, National Oceanic and Atmospheric Administration's release of its annual greenhouse gas index, which showed that anthropogenically sourced greenhouse gases, including carbon dioxide, methane, nitrous oxide, and other gases, were continuing to rise. However, one astute reader, an engineer and scientist, the late Ken Saunders, wrote a response to this report saying, and I quote, I want to comment that the way dominant greenhouse gas in the atmosphere is not mentioned in your report, namely water vapor. Water vapor accounts for about 97% of the total natural plus man-made greenhouse warming of the planet. And he references Saunders, John Houghton's The Physics of Atmosphere, which is a standard text. And then MIT's response to this, okay, is this. This is true. Water vapor is the major player in the greenhouse effect and is often omitted from reports and reporting about global warming. So, why would you leave off talking about water vapor? So now, since the first estimates of water vapor injection into the stratosphere were published in August of 2022, more accurate estimates have resulted from additional studies and analysis by the European Geosciences Union. Research meteorologist and hurricane expert Ryan Maui discusses the findings of the EGU in a recent blog post. Quote, initial scientific estimates were 50 million metric tons of water injected into the stratosphere by Tonga submarine volcano. However, it's likely off by a factor of 3. New research suggests that 150 million metric tons, or almost 40 trillion gallons of water vapor, was injected into the upper atmosphere. A lot of it is still up there floating around. End of quote. Now, I would ask this question. If 50 million tons of water vapor added to the atmosphere could create a real possibility of a global warming effect, what would 150 million tons do? 150 million tons. So now I'm going to quote who used to be highly respected climatologist Judith Curry, who was with Georgia Tech here for many years and was held in high esteem by the global warming factions, but then fell out of favor when she realized that there were serious errors in the data, and she corrected some of her own thinking and writing that's now contradicted the mainstream narrative. She ended up actually having to resign from Georgia Tech over this. But she still studies the climate. She blogs about the climate, and she is, in my mind, even to be more respected because of the fact that she stood by her convictions, stood by her interpretation of what the data was actually telling us. So this is a quote from her. The recent warming in the spring/summer of 2023 is associated with a spike in the net radiation flux at the top of the atmosphere. This spike reflects a combination of an increase in incoming shortwave, a decrease in high-level cloudiness, and the impact of ship sulfate aerosols, reduced snow ice extent, and the Hunga Tonga eruption. So, as far as these influences are concerned, Professor Curry then says, I quote, all of these factors are arguably in play to some extent. The issue is their relative magnitude. Now, the thing I want to call attention to in that quote of hers is the spike in net radiation flux at the top of the atmosphere. Well, what is causing that? I'll quote directly from Curry again. We can gain some insight into what's going on from looking at satellite observations at the top of the atmosphere radiation fluxes. The net flux at the top of the atmosphere is incoming solar radiation minus reflected solar radiation, which is coming reflected from the Earth, minus outgoing long wave radiation. So let me break this down a bit. First, incoming shortwave radiation originates from the sun. Some of this radiation is reflected back into space, so plays no role in heating the lower atmosphere, okay? But some of it penetrates the upper atmosphere to reach the ground, where it is absorbed. The long-wave radiation, which is then re-emitted in the infrared band, results from the radiation being emanated back to space from the Earth, where some of it is captured by water vapor, most of it by water vapor, carbon dioxide, and other gases, while the rest passes harmlessly out of the upper atmosphere. It is the captured radiation that is involved in the greenhouse effect. So she continues by discussing the graphs of radiative energy balance. Quote, there is an overall increasing trend. The signatures of El Nino and La Nina are seen, with net energy loss during El Nino years and net energy gain during La Nina years. The data extends through May 2023, showing a very strong spike in the net radiative flux in April and May. And to what do we attribute this radiative flux, the spike in radiative flux in April and May? Quote from Curry again, you can see the 11-year solar cycle in the incoming shortwave. And in 2023, approaching the peak of the solar cycle, the sun is the brightest it has been for the past 23 years. Okay, let's break down what I've covered so far. I haven't even talked yet about the inaccuracies that were provided, the data on which all of these claims were made, which is the climate reanalyzer. But from what you've already seen, you had the water vapor, right? Now, how much would that water vapor affect the temperatures? Well, measurably, yes, indeed. We're also got Judith Curry pointing out that the sun, the radiative flux of the sun, was at its brightest in 23 years. So now nowhere in any of all of this was carbon dioxide named as a culprit, was it? And so here's the thing, and that we got to get into, is this. Mainstream media never breaks it down where people can really understand the specifics. Because what they're doing is taking the data, they're reporting it selectively in such a way that it can actually be used for purposes of propaganda. And so all of these things that we've talked about here, the role of this increased intensification of water vapor that undoubtedly caused regional warming and could have easily contributed to local or regional records being set. The fact that the radiative flux coming in from the sun is at its strongest and is going to obviously leave a signature within the temperature record. And then these other factors. So it's very much like with the Maui fires, right? It's all selective. It's how do you take these natural situations, these natural events, and weaponize them or turn them around and turn them into global warming propaganda. And how you do it is you simply ignore, just like it said, why do they ignore the role of water vapor? 97% of the heating is water vapor. Yet in all of these discussions, why is it ignored? Well, I think it's obvious. And why is the role of the sun ignored? But what people who do not bother to dig into the facts, dig into the evidence, and do their own research, they only see the headlines. And the headlines are designed to cause fear, to scare people, to induce panic that, oh, something has to be done. So we're going to give up our freedom, we're going to give up our power to an almighty bureaucratic state who's going to save us from our own activities, from our own behavior.
Yeah, and it's hard to blame. It's hard to blame the water vapor on the energy industry, right?
Yes, it is. Yes, unless somehow the energy industry was responsible for the hunga tonga hunga. I like that, hunga tonga. Can you work that into a song lyric, Kyle? You think?
It can be done.
Samoans already have.
Right. So
maybe that's a good
segue
way to switch because we're over an hour in here.
Yeah. Okay, so when we come back, we're going to take a little break. When we come back, I'm going to do like a first level discussion and some disclosure about the whole energy thing and maybe address some of the controversies, which I suppose were entirely predictable when, rumors get started and people pick up on disinformation. There was a lot of disinformation out there that people found from 25, 30 years ago that they took and ran with it, and they got so distracted by that they failed to actually look at the evidence itself. So we're seeing a repeat of what happened with Graham Hancock. Let's distract people watching this ancient apocalypse or reading Graham Hancock's books. Let us distract them with accusations of white supremacy, racism, conspiracy mongering, et cetera, et cetera, et cetera, and then distract them from actually looking at the data and the evidence that Graham has collected and presented. And we see the same thing now happening with Kennedy Jr., Robert F. Kennedy Jr. If you look at the mainstream media coverage of him, you see the exact same thing, which is he's a nutcase. He's a conspiracy monger. He's, quoted out of context. It's basically your classic hit piece or smear strategy that they employ. And there was certainly an element of that associated with the reveals of this energy system and alternative energies. We'll get into that somewhat. It's just disappointing to me that there were so many people out there that fell for it and just took that at face value, didn't understand that they were looking at propaganda, and then based on that, they didn't invest the time to actually look at the data, look at the evidence. We will look at some of that when we come back because there have been some milestones crossed in the last few months over the summer.
All right.
See you in a minute.
Okay, we'll take a short break. Thanks for all of you that have donated. We are paying attention. I will try to at least get to your names at the end. Maybe not the questions. We'll see. Thank you guys so much. We'll be right back.
And we're back, ladies and gentlemen. Kosmographia Live. And I guess we're getting into the alternative energy sources discussion.
Dun, 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 dun.
Dun, dun.
Let's hear it.
Everyone's
Randall.
been waiting,
What
Randall.
do you got? Yeah.
Show me
On
what
hold
you
for
got.
9 months.
Well, I just received a message. I'm not going to be able to say anything about it. It's
Oh, okay. Well, thanks everybody
I'm
for
sorry.
coming. We're going to sign out.
NDA took effect right at 9:59.
no, that didn't actually happen.
You're a
But,
troll, Randall. See, he's a troll, folks. He's trolling you guys.
Well, hey, they can dish it out. They can take.
Yeah, I
it, right?
agree. I agree. Yeah.
They deserve it.
So, where do we start? I think that I will just say that, there's been a lot of controversy and discussion about it. I mentioned, without getting into a whole lot of it, let's just say this, that the backdrop of this, and this has been, I've been able to confirm this and verify the truth of all of this. I've had a long discussion with Roland Perry. Now, would you look him up, Kyle? Can you do that?
I can.
Roland Perry. He's an Australian author. I think perhaps one of Australia's best-selling and most prolific authors. He is also an investigative journalist. Did you find anything about him?
Yes.
What is it? So he came right up, didn't he?
Yeah. Born 11th of October, 1946. He's an Australian author and historian. His work includes 3 works of fiction and more than 20 documentary films.
Mm-hmm.
You want to hear more?
Yeah. That's enough. I mean, so he's a real guy. And he's also an investigative journalist. So he spent 4 years investigating Malcolm Bendel, okay, who's the controversial character who's the primary inventor, although, as he will say, a lot of the ideas didn't originate with him, that he was built upon the shoulders of those that came before him. And he just picked up where a lot of their work left off, which unfortunately oftentimes met with a premature termination due to primarily politics and other such things, going back to Nikola Tesla. And so elements of what Bendel has explored and researched began with Tesla's work and has come back down through, quite a few others. Given that he's in the big movie now, Oppenheimer, before he got drafted to work on the atomic bomb, he was exploring various types of alternative energy, and some of the things he came up with provided actual, insight and data that Bendel was able to use. And then, of course, Walter Russell, if you know him. Ken Shoulders did a lot of work in the alternative energy field, just passed away a few years ago. So there was a lot of people that came before. Stanley Myers was another one. There was probably 8 or 10 individuals who did key work leading up to Malcolm's work. And then he took it basically to the next step. So anyways, in my discussion with Roland Perry, who knew and has become friends with Malcolm, who did the investigation, he became friends with him over the course of doing this 4-year investigation. He was a geochemist. Malcolm is a geochemist, amongst other things, and was an oil prospector. And I'll just give the very most brief explanation here. He discovered an oil deposit at a time when one of the major oil companies had overstated their reserves by 30% and found themselves potentially in a major pickle, because if it got found out that they had overstated their reserves, their stock value would collapse. And basically what you had was your archetypical David and Goliath situation. So he's an independent oil prospector, discovers an oil, gets licensing from the Tasmanian government to do exploratory drilling. And then this major oil company, which I'm not going to mention any names, but if people want to do the research on their own, they can do that and they'll find out. But the oil company wanted to get possession of the licensing. So what they did was they went on a smear campaign to discredit Malcolm and present him as a total nutcase. And they bribed journalists, they bribed local politicians in order to try to get possession of the licensing. Well, ultimately, their efforts failed. They got exposed. In 2003, the entire board of Shell, or maybe not the entire board, but the top level, oops, I just said it. But anyways, okay, so there we have it. They had to resign because of the scandal. But that's a good thing. Here's why it's a good thing. Because what the battle over these licensing rights led Malcolm to decide that he was going to get away from the politics and the conspiracies that were going on in the oil industry and get back to what he had been working on since he was literally a teenager, which was alternative energy. So he shifted and then began to focus on these ideas he had, and he began to develop prototypes, built prototypes. He was able to take her, he's ultimately Australian, he was able to take refuge on an island undisturbed for 7 years while he perfected his theories and built these prototypes. And he brought some highly qualified mechanics and engineers to build the first generation of prototypes. They tested them. The tests were successful. And then I went on the Joe Rogan show and mentioned his name and where he was located. And as a result of that, he decided to go ahead and leave his sanctuary on the island, and he came to the United States. So shortly after that, he came here, and we spent the next 3 months while he coached me in the principles of this energy technology. Okay. Well, during this time, while I'm learning about it, I'm like, see, now, of course, now let me say this. I've had conversations with him, multiple conversations, first starting about 8 years ago. And when he first called me, he basically told me that he had seen some of the videos, which actually Brad had posted on the geocosmic stuff. He'd seen some of the geocosmic stuff that Brad posted on sacred geometry lectures, and it perfectly dovetailed with what he was doing. In fact, even gave him some additional insight that he then incorporated into his overall plasma unification model that he calls it, right? So that's why he originally reached out to me, and we began this dialogue. And during the thing, I'm trying to wrap my head around what he's explaining with, only marginal success. And then, of course, wondering, okay, now how much credibility should I be putting into this stuff that I'm hearing, that, he's able to do this and that. And so this went on until I began to, well, actually, two things happened. One, I met somebody personally and had a meeting with several individuals that were involved with helping finance his initial attempts at actually taking applications of these principles based upon plasma physics and applying to the creation of a technology. So I met one of the investors that had bankrolled the creation of the construction of some of these machines for testing, and I met several other people that were involved. And now these were highly credible people that were actually some of them were retired professionals from the industry, the energy industry. Others were major players on a global scale. I'll come back to one of them here in a minute because I'm going to read the latest prospectus here from the company that's handling the stock issuing that's going to be happening. Anyways, after meeting with those guys, they confirmed, pretty much were unanimous in their opinion that, yes, we've seen the technology and it works. One of them said to me, after we had our meeting, we went down, there was a meeting of four of us, then two of them had to leave. I went down, had dinner with the other two, and one of them says, I've been looking at this. I don't know how it works. It works. I said, so I went away from there and my confidence was bolstered considerably after meeting these guys. Then I had this conversation, about an hour-long conversation with Roland Perry about all of this stuff that had happened back in the 90s and early 2000s. And he pretty much clarified and confirmed to me, yes, that most of it was just a deliberate campaign to discredit him and to paint him as a shyster. And of course, you know, at the time I'm looking at like what happened to Graham. You know, if you took those mainstream reports on Graham Hancock, and you don't know anything else, you don't know him personally, you haven't read any of his books, you don't know anything about him, you're going to come away with this impression he's a really not a savory character. He's a white supremacist, he's a racist, he's a conspiracy monger, whatever else, wife beater, who else, you know, kills little furry animals or whatever it is that you imagine that he does. That's the impression that you come away with, right? But we all know Graham, we know his work, and we know that it's all complete BS. You know, all that stuff that came out in the aftermath of Ancient Apocalypse was 99% BS, and it was just the way it was spun in the narrative, but never addressed any of the actual questions that he raised or the facts that he brought forward. Okay, so it's that typical hit piece. And it's what we can see, for example, going on right now with Robert F. Kennedy Jr., because he what he dared to say about what that you're not supposed to say to be on YouTube, it didn't go against the officially sanctioned narrative. And so now all you have to do, read the accounts of mainstream media talking about what a nut job he is, you know, that he's conspiracy, that it's conspiracies, all of this stuff. But again, if you read it carefully, where's the facts? Where's the evidence? And this is something that's critically important, I think, for Americans, is that they learn how to recognize propaganda. And in fact, Joe Rogan himself was the subject of that, because he dared to have some dissenting doctors on his show, remember, who were questioning the whole narrative, the pandemic narrative, and he was getting canceled. People were calling for him to be banned. You know, you had Neil Young and others saying, well, we're gonna take our music off of Spotify if you allow this guy to continue on. And they basically attacked his character. But nobody in all of that smear campaign did they actually say, well, let's look at what Dr. McCullough had to say, or the other doctor that he had on. Let's actually look at what he had to say. So again, the propaganda tends to ignore the evidence. It ignores the facts. It attacks the person, tries to discredit them. And this is exactly what went down. This is what went down. And so many of these people look up, you know, and this is the shit that they find, and then they think that's it. Now there's, you know, but because they're gullible, they don't understand and recognize blatant propaganda when they see it. And so what happens is that acted like a big obstacle, and all of the further interest in lots of people just came to a screeching halt because they saw this stuff. It did what it was designed to do, discredit this inventor. Okay, so and it's the same story that's happened to everybody who's come up against something that establishes these political, economic, corporate monopolies. Okay, so it's too bad but there were a few. I know there's some people out there who have gone ahead with an open mind and began to look at the notes that have been, and that's the schematics and the diagrams and the photos and the videos that have been open sourced. All right. The problem there is the key was to dump this stuff and get it out there as quick as possible. Right. So there was no time to put it into a coherent, organized form that somebody, a novice, such as myself in this, could begin to go in and systematically learn about step by step the technology, the science behind it, what plasma physics was all about. So that is really ongoing right now. And there's been new people that have come in the last 3 months now. 3 milestones have been passed. One, the first industrial scale application of the technology in in Europe. Actually, I can be as specific as saying it was in England.
This would be like a full generator, or
yes, a 400 kilowatt Pierce generator.
Okay.
That is part of a power management station that actually feeds into the London power grid. Okay, we can say that much. Okay. However, this generator, for purposes of testing, was taken offline.
Okay.
Right. And my understanding is that there are officials right now from London. Yeah, we can say that. I think that's fine to say that. So I'm just being overly cautious because of what happened on the. Before I go into, let me make one more caveat here, and that is here's what's happened. People have had a lot of questions about the so-called lost episode of Rogan. Okay, so I went on Rogan. I was on there with Graham Hancock, and the question of ancient energy came up, and I mentioned, and if you go back and watch it, you'll see that I'm kind of reluctantly, confirming that possibly, that some of the stuff that's being explored right now might relate to the idea of an ancient energy system being used in the past, in the historic or prehistoric past. That led to Joe asking me to come back on to talk about it. And I agreed to do that, which in retrospect was kind of premature, because I'm still in the early stages of really trying to wrap my head around the specifics. Now, in fact, when I went out to be on, Brad was there. Brad has seen the suppressed episode, and he knows what went down. But basically, it was this. Because Bendel came to America, and I was in that phase I mentioned, we were in the phase, Brad was there too. We were both getting tutored in the science behind the technology. We built this 243 slideshow, and we're gonna look at some of that in a minute here. And then Malcolm did a series of about 10 hours of lectures where we had it up on the big screen, and he's pointing out things and explaining what we're looking at in this slideshow. So he was here. We were in the midst of this tutoring period when the scheduled appearance on Rogan came up. So Brad and I, George Howard, who else? Stephen Tuggle, who's my assistant, Brad, the four of us drove out to Austin. And since Malcolm was here, I didn't want to just leave him, so I invited him to come right along with us and see some of America. He's from Australia, right? So we went out there. In the hotel, I called Joe up and I says, just so happens, you want me to come back here and talk about this energy. Well, I just so happens that I have the inventor. He's with me, and I could bring him on the show if you thought that was appropriate. And I sought his permission before I invited him. So he says, sure, bring him on. So we did. But when we get there and sit down, Jamie had pulled up a bunch of this stuff from back in the late 90s and early 2000s. Boom, had dropped it there on Joe's desk, and Joe is looking at that when we walk in. So I came in with the first iteration of the slideshow that we had been working on. It wasn't complete yet, but I had the first iteration of that. With my intention was to spend the time talking about the science and the technology and looking at some of the ancient traditions that have suggested that this type of a science was known to the ancient world, that maybe some of these modern discoveries were actually rediscoveries. And so I was excited about, let's talk about the science and the potential technological applications. I had some video clips. Well, the whole thing turned into sort of a contentious interaction between Malcolm and Joe, because Joe immediately assumed that Malcolm was, a Barnum and Bailey con man and all of this, because he'd only just seen, he knew none of the backstory. He had only seen this stuff that Jamie had pulled up. And so what happened was the discussion got derailed into politics, into scandals, into conspiracy theories, all of which I had looked into, had found out enough about to find out that there wasn't much, if anything, there. And what really the focus should be, and the question really should be on the technology, the system that he's come up with, the inventions. Does it work or does it not work? Right? I would guess that you could go back and take every inventor of every innovative technology that's come down the pike, and if you did an in-depth examination of their lives, they wouldn't necessarily turn out to be completely angelic without sin. Because we're all, think about it, we could even do a smear campaign probably on Kyle if we wanted, and make Kyle look like this horrible person.
Hey, whoa.
Yeah, you could only do that to him by association with me.
Well, yeah, we would come and we would be we would be interviewing you for our primary source of information, of course.
Yeah.
Or maybe the other way around.
I'll also say Ben from Uncharted X is in the chat, and he pointed out that Tesla was an antisocial weirdo, who wasn't able to get along with people, and he claimed he channeled whatever. So, but we still use his inventions in the power industry today in electrical transmission. So
thanks, Ben. Excellent point. Yeah. Excellent point. And that's the thing, is that a lot of times geniuses are eccentric, and that's just to be expected. Wait a minute now.
Are you pointing at me, Brad?
Yeah, that guy.
Who are we pointing at there? Oh. Now, you couldn't possibly be pointing at me because I'm completely and totally normal. Right?
And you have a clean background, no arson.
Oh, that's right. No arson in my background. Oh, God. So this is the Confessions of Randall?
No more live shows. This is
no more live shows. This is it. So really that's the sum of it right there. So at the end of it, and while this is going on, if it ever gets aired, which actually it would be better if it didn't, right? Because it would just be more distraction from what really we need to be looking at. But if it does, you'll see in there that there are multiple times I'm trying to steer the conversation back to the science. And, I kind of get where Joe was coming from. He kind of went into attack mode, and he was going to expose this guy that was sitting on the table across from him, right? So instead of focusing on the science and the traditions that might have led up to it, it went sideways into all of this other stuff. And as it's proceeding, I'm thinking, oh God, if this goes out, it's going to be, I imagined that already the stuff, and we saw just without the episode being aired, the rumor mills started cranking and people started speculating, imagining this and that, and totally doing what propaganda set out to do, distracted people from going, well, let's forget about that shit for a while and actually look at the scientific basis. Is there a scientific basis for this, right? So the result was that after it was over, I'm thinking, if this airs, it's going to be just more controversy that's going to really distract from what I was wanting to really focus on, which was the science of it. And I thought, not only is this going to be a huge distraction from discussing the science, it's also going to probably have major repercussions on the Randall Carlson brand, my name, all of this kind of stuff. Joe comes out at the end of it and says, hey, would it be okay with you if I didn't air this for a while I vetted it? And I said, absolutely, man, don't. It'd be better not to put it out there, because all it's going to do is throw a bunch of dirt out there that is going to distract people. And I said, yes, I will be happy to come back, just myself. We'll talk about this. And so in the interim, I've actually, we all came back, Brad and I, Mike Robertson of HowTube, the three of us finished up the slideshow. Brad and Mike recorded the 10 hours of lectures. So I think we all could say we came away from that richer, knowing about the science. But still, like now I might consider myself in grade school. Back then I was in kindergarten. Now I'm in grade school. I've still got a long way to go. And what I'm feeling somewhat vindicated in not having a really sophisticated understanding of the science itself, because since then, there have been a huge group of highly trained professionals and experts that have come in. And we're going to talk now about the London build. We're going to talk about the Tesla convention weekend before last in Albuquerque,
Randall,
New Mexico. What's that, Brad?
Just let me go ahead and say that while we were doing that, getting that video done and completing the PowerPoint show, right, that he's done the 10-hour lectures that's on HowTube, we did live show 21, so people can go back and watch that, and that's the most views we've had on any of our live shows, people trying to get some more info about that missing Rogan episode and what our perspectives of it were at the time. So yeah, it's live episode number 21, so people can go check out what was in our heads at that point.
Yeah, and again,
fresh off of coming right back from the Rogan show, and completing that early stages of what he wants to publicize.
Yeah. So, so to me, it's just better to let that lie, simply because, what's far more important is that people realize that the technology has been now tested at least by 6 independent laboratories and sources. And I had the opportunity of going to and witness the post Nikola Tesla conference testing. So here's what happened. We'll jump back to the London build in a second, because that was the first major milestone. The second major milestone was the live stream from the Tesla convention in Albuquerque. And so Malcolm brought the machine from England in suitcases. He had to take it apart to bring it here. He came with a physics student that's been assisting him for several months now. A very brilliant young man who is a student at Oxford and has been helping with the London build. He came here. George Howard was out there for that, participating, and a group of independent experts came in to evaluate a live stream here. So here's what they did. They bought a generator, and I'll come up with the specifics on the generator in a minute here. They bought a generator, and then they retrofitted it with the technology. But they ran into a glitch. The glitch was that the generator that they bought was defective. So they went out and bought another generator and took the technology off of the first one, retrofitted the second one, and 20 minutes before they were scheduled to go live, they were able to get the installation complete. I believe that I would have been there, except I was up in Colorado doing a presentation at the Gaia conference on ancient civilizations, so I regretted I was not able to participate in it personally. But Mike Robertson was there. There were multiple videos running, recording this live stream as it happened, so that there was no possibility of any kind of trickery or manipulation or taking video clips after the fact, and manipulating them to look. It was all right there for the audience to see, the in person, the live stream audience at home that's watching it. And you had a number of people high level people who had been contractors or who were involved in the aerospace industry, had been NASA subcontractors who were experts. And then there was a lot of course, for a Tesla conference, there was a lot of people there who'd been studying alternative energy for years, if not decades. The primary host of the place was Maury B. King, who wrote this book, Water, the Key to New Energy, Cavitating Electrolyzers and Zero-Point Energy. I will mention that one of the basic components of how this system works is through the collapse of cavitation bubbles. We'll come back to that. Anyway, this is just the bio of Maury B. King, who was presiding over the conference. He has degrees in electrical engineering and system engineering. Since 1975, he has been researching the zero-point energy in the physics literature, exploring how it might become an energy source via technology. He has given numerous presentations on the topic and has authored the books Tapping the Zero-Point Energy, Quest for the Zero-Point Energy, and The Energy Machine of T. Henry Morey. So this book, if you want to get, it's full of sources of all the kind of stuff that the research that was done by different people with schematics and diagrams. So again, since 1975. So the guy is pretty much one of the world experts on all of the research that's been done on these kinds of alternative energy principles. He actually made a statement, which is in the video somewhere, saying that this technology is decades ahead of anything else that anybody is doing. That's what he said. So anyways, let's look at some of Malcolm's original inspirations. And as I now understand the technology and I look at these things, I'm seeing things that I would have never seen before. So I'm going to do, let's see if I can get a share screen going here.
Also, I'm going to get that video that he saw on the GeocosmicREX channel and put it up on the Randall Carlson channel so people can see that class. And
okay.
It was about triplicities, the 111, 222, 333, 444 numbers.
Okay.
Yeah, so he got inspired by that.
Oh, good. Okay, so now let's see. Dadgummit, it's okay. Let's see. It should be able to.
Well, can I ask a couple of questions?
Absolutely.
This is not like what kind of energy are we talking about here? It's people are asking, is it free energy? It's not going to be
plasma
free.
energy, and we're about to get into that.
It's going to be maybe cheaper, more abundant, but it isn't like a free energy source, right?
No, it's not.
Still
free
requires
energy.
Yeah. Okay.
It is not. Let's get clear on that. We're not talking about free energy.
Yeah.
Talking about making current like combustion engines more efficient and stuff like that.
Yes.
And also power generation in general, right?
Power generation in general.
Yeah.
That's right.
The thing they're testing in London is like
exhausts.
Yeah. Okay.
Is a starting point, right? You can't just jump to this galactic hopping spaceship.
But let's mention
Come on, Brad. Why not?
I mean, well, he wouldn't make it till tomorrow.
So there are 4 states of matter: solid, liquid, gas, and plasma. Solid, the electrons and the neutrons are bound solidly together. There's very few degrees of freedom there. You get to a liquid, there's more degrees of freedom in that there's less of a bond between the electrons and the neutrons. When you get to a gas, there's even less, but they're still bound together. When you get to the 4th energy state, which is plasma, the electrons and the neutrons are completely disassociated. So now you have electrons and ions, and this is where it gets really interesting because they have a tendency to self-organize according to certain geometries. And if you can essentially assist in the formation of those geometries, you can get a coherent organization of plasma. Now, plasma in nature, lightning bolts are plasma. Northern lights are plasma. In fire, there's plasma. The sun, plasma. When you have a coronal mass ejection, that's plasma that's being thrown off of the sun. A ball lightning is plasma. So it's all based upon controlling and influencing plasma. And again, plasma has this natural affinity. It's drawn towards specific geometries, most specifically that of the torus, right? Now, if you picture a torus forming, now we'll come to in breaking down the components of the technology, there's basically 3 components to it. One of the components is a plasma generator, and it's based upon extraction of plasmas formed in water as opposed, say, to air. And water is definitely the preferable source of your plasmas for various reasons, okay? Which we're not going to get into because there's a lot of details to unpack here, and we're not going to spend a whole lot of time because we can do follow-up presentations about this. And also, there's a whole new set of videos and things that people can go to learn about it. But in this second phase, which is the plasma generator phase, you have bubbles that are formed, macro bubbles that you can actually see, and micro bubbles. The micro bubbles are the key here because unlike the macro bubbles, the micro bubbles are perfectly symmetrical. And through a process of alternating vacuum and pressure that's generated automatically by the movement of the pistons within the generator or the engine, what happens is the vacuum creates the bubbles. The pressure causes the bubbles to collapse. And the microbubbles, when they collapse along, imagine that you've got an axis, and then as they collapse, they're folding in on that axis, and they meet at the equatorial plane of that spherical bubble, right? Now, what naturally then happens is it starts this movement, this flow of electrons spiraling in a vortex down the center of that torus. And you've got a clockwise vortex in the northern hemisphere, say, and a counterclockwise in the southern hemisphere, and they meet at that equatorial plane. And that is what is referred to as the 0 point. That's the 0 point, and that's where the magic happens, okay? So the second component is this plasma generator, which is nicknamed the bubbler because it generates bubbles, okay? Through the process, the direct process of the compression and decompression that's caused by the moving pistons within the engine or the generator. So it relies on the mechanical moving parts of the generator to generate the plasmas. Okay, so I think what I'll do here is, let's see if I can pull up. I'm going to save the archaic stuff for now. And so reading here from, this is, let's see, where did this come from? This might be from, sure if this is from Roland Perry. This might be from Alpha Prospects. I think they wrote this up. I've got my source. I can find it here, but this is all going to be online. This is online so people can access it themselves. Australian Malcolm Bendel has invented a proprietary MSAART, which the Australians pronounce MSAT. MSAT plasmoid-induced and controlled atomic energy release process from protium, which is hydrogen, which allows water to be used as an atomic fuel. And that, again, is the whole basis of Moray King's work and why his book is entitled Water, the Key to the New Energy, because it splits apart the hydrogen and oxygen atoms. So it goes on here. When deployed as a retrofit on an engine, this innovation is known as the thunderstorm generator. Using this novel technology, conventional engines and generators can be retrofitted to run on a combination of water in its gas phase and fossil fuels, producing negligible toxic emissions when compared to current outputs. Existing hydrocarbon fossil fuels, such as petrol, kerosene, diesel, and gas, are solely used to achieve the initial operating temperatures in vacuum, because you have to get up to a certain temperature in order to create the plasmas, to create this dissociation between electron and neutron. However, the first component of the technology is a preconditioner of the air, which makes it possible to use lower temperatures to cause that dissociation. This is required to begin the creation, capture, and harvesting of the stored atomic fusion energy contained within the water. So Bendel has invented a proprietary MSAT, plasmoid-induced atomic fusion process, which allows water to be used as an atomic fuel. So when attached to an internal combustion engine, it generates energy from a combination of water in its gas phase, plasma, preconditioned water, the original fossil fuel, the motor's vacuum, and the recovered exhaust gases. Tests performed on a working MSAT plasmoid energy engine prototype have proven the ability, the utility and efficiency of the engine heralding the start of a new sustainable industrial revolution. And quoting from the Alpha Prospects limited public discussion of their investment portfolio, they are out of England, and they're handling a number of the patented applications of the technology, one of which is a retrofit of coal stack chimneys, scrubbers that use this technology. Okay. So quoting from their prospectus, actually, I can show it. It's this right here. This technology gives unprecedented reduction in harmful emissions while simultaneously dramatically increasing oxygen levels from near zero to near normal atmospheric levels in engine applications. Okay, so I'm not going to get a whole lot at this stage into trying to get into the technology of it.
Does it use water as fuel, or can the water just be reused? Is it like a closed system?
The water is being reused.
Okay.
It's completely a recycling system.
So it doesn't require So you just fill it with water and then you can go. And as long as it doesn't over long term change the properties of the water to something that is not useful anymore.
I don't think that happens.
Okay.
I don't. Good question, but I don't think that happens. So let's see. Let's get to some shared images.
It makes sense that just like oil, you'd want to change it annually or something after so many. But it's a separate closed system, like you said. Once you add it, it's in there.
Okay. So let's see here. Go to that.
He said the Australians, right, say MSAT. So if you're going to do that,
MSAT,
you got to do the dialect there from them.
So once a year,
there's an R in there, so it's MSART, but they say MSAT.
Yeah, MSAT.
MSAT. Yeah.
So once a year, you pop the thing open, you drink the water out of there, and you pour new water into it. Is that what you do?
It gives you leftover plasmoids.
It's like a Red Bull or something. Gives you.
No, I
don't know about that.
I haven't heard that for sure, but
Okay.
but you don't have to add it with any regularity. Is what I've gathered.
Right.
All right, let me know if you see this.
Screen sharing coming up. Yep.
All right, good. You are screen share. Hey, I got a little message box telling me that participants can now see your screen.
Excellent.
Has that ever happened before? All right, let me move that out of the way.
Program updated. Yeah, go.
You can see here's one of the early attempts to find applications for the technology. And let's see here. Okay, you see this thing right here. This is the bubbler. Let's see if we can find another image where you can see this is the bubbler. This is the water intake here. This is I believe that would be the pre-ionization chamber, where the air being drawn in is pre-ionized by subjecting it to ultraviolet light. In frequencies, if I recall, we're around 100 microns, but the key thing here is that when these microbubbles collapse into toroidal geometry and the plasmas are formed, they release a burst of ultraviolet light. And so the pre-ionization chamber exposes the air to the same frequency of UV radiation as is being emitted in the formation of the cavitation bubbles. All right, here here's the plasma generator right here. And there's water. It's water in there, and it's simultaneously being subjected to vacuum pressure. The vacuum forms the bubbles. The pressure causes the bubbles to collapse. and it's in the collapsing process that the plasmas are generated. This over here, I'm guessing, would be the pre-ionization. I don't see anything else. This is probably, I'm thinking this is maybe a muffler. Oh, let's see.
Is that not the vortex?
No, let's see. Tell you what, I don't know if people
exactly
would want to see this. We could look at this very quickly. Let's see if I could do this. This is Roland Perry, again, Australian author, introducing the plasmoid car. And it's kind of rough around the edges. We could try. Let's see what happens
we're pushing 2 hours, just FYI.
Yeah.
Well, let's keep going then. Let's keep going because we're going to do follow-ups on this. We'll be doing multiple follow-ups because okay, here's the build out of a generator in Ketchikan, Alaska. This is the mechanic that built it. And it took him, he said, I think between 4 and 5 hours, once he had the components, between 4 and 5 hours to actually retrofit the generator. Right here, this thing is the pre-ionization chamber, and here is the plasmoid generator right here, which they call the bubbler. Now, in a larger scale application, each of these 3 pipes here are plasmoid generators, and here there is a clear plexiglass part of the tube so that one can actually see the process underway. Let's see here. That's Mark. Okay, so here, great. So here is another test of the technology fitted out with onto a generator. You can see this is the generator here. And looking at this, here's your pre-ionization chamber, and you can see this tube leading down into the plasmoid generator. The bubbler's down here. And then that leads back up into the key component of the whole thing, which is this, which to me is pretty amazing, which is the so-called thunderstorm generator. And what I'm going to tell people to do, if people who really are trying to understand this, like I am, like Brad is, and a lot of us others who are now really diving into this to try to understand what's going on, look at the Hiltsch vortex tube, HILTSCH, because the principle of the Hiltsch vortex tube is the inspiration behind the thunderstorm generator. And it's so-called because it literally recreates a thunderstorm within these 2 spheres. Again, all we can do today is, and here you've got it's hooked up to a Bosch analyzer, which is reading the you can see right here, the analyzer goes into the exhaust pipe right here. You see that? So what's reading out here is what's coming out of the exhaust. So in this particular test, it was hooked up to the generator. And in the video that you can watch, we're not going to play that video because of time, but Gary Ling here, who oversaw the testing, he recorded it, and in this video you can see that they'll alternately turn the technology on and turn it off, turn it on, turn it off, and then you can see real time what's happening with the Bosch analyzer here in terms of effluents coming out of the exhaust right there. And you can see you can see the methane, the carbon monoxide, the carbon dioxide, the nitrous oxides are all going down very close to zero if they don't actually zero out. At the same time, the oxygen, which is hovering around 4%, which is typical for the exhaust from any internal combustion engine, goes up to 19, 20, almost 21%, which is going to be your optimum oxygen percentages in clean, unpolluted country air, if you want to put it that way. Okay, so let's see, that's Malcolm. Okay, so here you
just that I made a compilation of these short videos that are included in this PowerPoint show, and that should be on HowTube. If it's not, I'll make sure Mike gets it up there because
okay. So here's the plasma generator, and here's the thunderstorm generator. So all of this is just hooked up in line with the carburation system. Okay. So here's you can see water intake, pre-ionization chamber. You can see that's piped from the pre-ionization chamber, comes down here, and then is fed up into the bubbler, into the plasmoid generator. And then that in turn is fed into, this is the thunderstorm generator here. And then that's where the atomic reconstruction takes place. So we'll just go through these. This is another independent test going on here in a different laboratory, in a different shop, a completely different retrofit site. Like I say, I think there's been 7 testings that have been done now. Here we go. This is a great depiction.
And
here
what have they found? Basically, like emissions drop and efficiency goes up? Is that the...
Efficiency typically will double or more than double. Power output increases. Effluents that you would think of as polluting go way down or zero out, and oxygen comes up. And there's a video. Our good buddy George Howard was out at the Tesla convention. They had the thing out on when the first generator didn't work, they had to go get another one. But they didn't want to run the generator inside until they had everything fixed up, because of course all of the exhaust fumes are coming out, and I think there was burning diesel, so it didn't smell good at all. However, after they finally got the technology hooked up, turned it on, they had actually a mass spectrometer there, in addition to 2 different kinds of analyzers that were brought by independent researchers. Okay, this is the thing you have to bear in mind. These are independent researchers who have brought their own equipment to do this testing. And the oxygen level went from somewhere between 4 and 5% up to, I think it was 20 or 20.9%, right in that range. Old George, he gets down and started huffing at the exhaust. So we've got that on video. George Howard huffing plasmoids. Okay.
Classic.
Yeah. The next one here shows, this is the outfitting of as it says, G35080 retrofit of an industrial scale generator here. And you can see here, look at this. Here's your thunderstorm generator here. It's attached to this large generator. I'm not sure the capacity of this generator, but here you can see the bubbler. These 3 pipes are all bubblers that are producing plasmoids that are then being fed into the thunderstorm generator. Thunderstorm generator. And then that's being fed right here into the generating system. And this generator is now using plasma as its fuel. So here it breaks it all down. Thunderstorm generator here. This one only has 1 sphere on it. The London build has spheres on both ends, which amplifies the efficiency and power. Here's all your gauges, your electronic control panel, exhaust gas analyzer here, your Bosch engine analyzer. Here's your bubbler. You can see again here how it's fed in. Now, here's the thing you got to keep in mind. There's 2 concentric pipes here. This is a 12-inch pipe, and inside it is an 8-inch pipe. And when people go and look up the Hilch vortex tube, you'll see that the Hilch vortex tube works by 2 vortices of whirling air. The outside is going to be your hot air, and the inside is going to be your cold air, and they're moving in different directions. When we have a follow-up to this, we'll get back into the functioning of the Hilch vortex tube. Interestingly, if you read about it, you can go on Wikipedia, you can go, there's a lot of sites that talk about it. They'll all admit pretty much that it's been in use for decades, but nobody understands what the hell is going on and how it does what it does. But it works, so they use it. So again, we talk about this in greater detail, but you've got a 24-inch stainless steel sphere here. Inside it is an 18-inch sphere. And so you can see this 6-inch pipe comes up here, and that runs down the middle of this larger outer tube. And so what you have here is you have 2 vortices whirling through this pipe. You have the outer one that's between, you have the hot one that's between the outer pipe and the outside of the inner pipe. and then you've got the cold one running on the inside of the inner pipe. So if you can picture what's going on there, it'll help. And then understanding the principle of the vortex generator, the Hilch vortex tube, because it's essentially the same principle. There is a 0 point here where something really, really interesting happens. And again, we'll save that for later. But if you go online, you can begin to see we've got the schematics are up there. We've got videos to help explain it.
Right.
And
just to connect it to some of the old ancient technology, potentially, where one of those tubes goes into the sphere, right? Is a particular angle.
Yes.
And it's the exact angle as the side of the Great Pyramid.
Yes.
Right. So there's something odd going on there that is going to
there are
some links potentially.
And I thought we would get into that. I don't think we're going to have time today, but like I said, we're going to be doing future podcasts about
overviews,
this as we're learning. We're going to be sharing it with anybody else who's interested in learning, doing your own research. One of the goals here, now this is actually a jet engine turbine that's being developed. So we'll have more to say about that.
That was the
retrofit
of an existing one. Yeah.
An existing one.
So
yeah.
This is the 243 slide PowerPoint show that Malcolm takes 10 hours to go through. So you can watch that. It's a series on howtube.com. He didn't get into it at the Teslatech. He started, but it was late night already. So he's going to do a quicker summarized version of this program, and that's going to be available, come out for free. And
excellent.
We're starting to work on that. Yeah, soon. So that'll be out. The summarized version of what Randall's going through now by Malcolm through the whole entire program of 243 slides.
Yeah. And here you're seeing a cross section of the outer and inner spheres and the introduction of hot exhaust gases, the separation into hot and cold, and it sets up this whirling, this high speed, that's high velocity whirling of the plasmas in opposite directions, the cold on the inside, the hot on the outside. And this is the key to how the whole thing works. Exhaust gases are introduced at an angle, first expand anti-clockwise and then contract clockwise as they pass through the cavity between the two spheres. This creates opposing tornadoes both within both the outer and inner spheres. And it's based upon the same principle that from nature. These expanding and then contracting tornadoes strip electrons and lay a positive charge on the outside surface of the inner sphere. And here I've got the next one actually shows the vortex tube. Also known as the rank Hilch. Oh, there's no T. Take the T out. HILSCH vortex tube, a mechanical device that separates a compressed gas into hot and cold streams. The gas emerging from the hot end, which would be down here, can reach temperatures of 200 degrees centigrade, which is 392 degrees Fahrenheit. Now get this. First of all, this is air being introduced into the vortex generator at room temperature, right? It now gets separated. There's no mechanical moving parts. It gets separated into these two vortices of whirling air, a hot one on the outside that can reach, as it says, 392 degrees Fahrenheit. Gas emerging from the cold end can reach minus 58 degrees Fahrenheit. So what's that? Almost 400 and getting up to almost 460 degrees difference between the temperature of the air coming out the cold end and the temperature of the air coming out the hot end. And what you're seeing right here gives you a basic concept of the thunderstorm generator. The two vortices are separated by the inner and the outer tubes. There are no moving parts. Pressurized gas is injected tangentially into a swirl chamber, which is this, and accelerated to a high rate of rotation. Due to the conical nozzle at the end of the tube, which you see down here, only the outer shell of the compressed gas is allowed to escape at that end. The remainder is forced to return, you see these arrows right here, in an inner vortex of reduced diameter within the outer vortex. Here's another.
So that one has, the original has no additional internal pipe, but
correct.
But Bendel's has the actual pipes are separating those two vortices, right?
Yes. And what they're calling here the vortex spin chamber, that's the function of the spheres. That's what's happening in those spheres that you see on the ends of these pipes. So, yeah, in this PowerPoint show, there's diagrams that people can look at, they can study. We've got schematics. You know, here's the pre-ionization chamber. Here's the bubbler, the plasmoid generator, and then the thunderstorm generator, what's going on there. And I would highly recommend that people do the research. Excuse me. And slowly but surely, hopefully, we will all begin to understand this technology. There's a lot to it. The electron scavenger, all of this stuff is external to what we've just seen, but are amplifications of the basic principles. So before we conclude, let's see here. Okay, so here's your basic torus, your collapsed sphere. So now what you want to do is look at this line right here is coming around like this and spiraling inwards down towards the 0 point. So the plasmoids naturally, of their own accord, began this spiraling motion down towards the 0 point. So this is happening in both hemispheres. And then what Malcolm has done is he's taken 16 cross sections of this torus and then discovered that all of the elements can be arrayed along that vortex. And this goes beyond the mere application of the thunderstorm generator technology for retrofits into a whole nother realm. We won't get into that, but it's really, really intensely fascinating. And the takeaway of it is that all of these atoms are vibrating at certain frequencies on the atomic level, and those frequencies and the ratios of them, as he's showing here, can be described by the sacred numbers, which to me is really interesting. And this is what he saw in the video that Brad posted, and he knew that the same numbers I was talking about that occur reiteratively in sacred geometry were the numbers he was discovering represented the resonant frequencies of the very elemental substances of matter. And then from that, he developed this plasma unification model. And this is worthy of study right here, because it unifies all of these various frequencies across the spectrum of various phenomena. In fact, we got posters. If anybody's interested, we're selling posters. We made a limited run of some of the posters of this because we thought there are people might want to be studying this on their own. And so if anybody wants that, I think we can go to randallcarlson.com. I think there's a link on there, and you can actually get one of these like large scale, like movie poster sized, and then there's additional information below this on the poster. And I think we'll stop this there, and then I'm going to just quickly show you a few slides from the London build out. We don't get to watch any of the videos because we don't have time, but anyways, so I'll just read this basic idea here. Pressurized gas is injected tangentially into a swirl chamber near one end of the tube, leading to a rapid rotation, the first vortex, as it moves along the inner surface of the tube to the far end. A conical nozzle allows gas specifically from this outer layer to escape at that end through a valve. The remainder of the gas is forced to return in an inner vortex of reduced diameter within the outer vortex. Gas from the inner vortex transfers heat to the gas in the outer vortex, so the outer layer is hotter at the far end than it was initially. The gas in the central vortex is likewise cooler upon its return to the starting point, where it is released from the tube. And let's see, I will go back to, what are you seeing? I'm going to stop share, and then I'm going to reshare because I changed programs, so you might have not been seeing this. Can you see this now?
Yeah, we see it.
Yeah, that's
okay, good.
Off. Yeah.
So yeah, here you can see an application to a generator, and so now hopefully all of those of you guys that are watching, you're beginning to recognize the components of the technology. Here you see the water intake here. Here's the air intake, which is into the pre-ionization chamber. They're mixed here, and then they're mixed here in this tube. They're fed down here, and then they come up through the plasmoid generator, and then from the plasmoid generator, they're fed into the thunderstorm generator, and from there, then into the machine, into the engine or generator, whatever it happens to be. The thunderstorm generator technology can be applied to any internal combustion engine, jet turbine, or heat-generating man-made or natural, irrespective of the input, hydrocarbon, or other fuel type. Fuel types tested by prototypes include gas, petrol, diesel, and oil. Fuels expected to have applications are coal and nuclear that are as yet untested. The size of the thunderstorm generator system is fractal. It can be scaled up or down in size, but the proportionate ratios are crucial to its function. And those proportional ratios, interestingly, and maybe not unexpectedly, come right out of sacred geometry. So that, to me, adds a really interesting dimension to this whole phenomena. And here again, showing the system, discussion of what happens in the pre-ionization chamber, the plasmoid creator or the bubbler. Then we've got the schematics there. And one of the things that we're very interested in doing is making this information available to backyard mechanics who can put something like this together, even pre-assembling some of the components or pre-manufacturing some of the components like the spheres and so forth that might be more complicated. And then, to make it to the level where backyard mechanics can retrofit automobile engines with it. Okay, so now here is a truck delivery to the site of chimney and internal combustion energy retrofit assemblies for testing. So there was two things. This is the retrofit concept for coal chimneys right here. So they were going to be testing this alongside the large-scale industrial application. Okay, so here we are. We're in the machine shop, and you can see they're assembling. This is actually a video. I'm not going to play it now because, again, we don't have time. This is Gary Ling again, who's overseeing the manufacture of the equipment here, and you can see they're putting it all together here. So all of this is being pre-manufactured to fit it to this 400 kilowatt generator. We don't have time. The diffuser is, the water is fed up through here and it serves a function. We won't talk about that now, but we'll come back to it. This is a very interesting video. It's the manufacture of the spheres that were used. And you can see that they're almost ready. Yeah, look at that. Now, what Brad mentioned, now it was found that only a certain angle between, this is the transition between the outer pipe and the inner pipe, and the angle from this rim to this rim is what Brad was talking about. That angle is 51.84 degrees, which was found to be the optimum angle to make the transition. Well, you know what 51.84 degrees is, right? Silence, right? What is 51.84 degrees? Did I lose you guys?
No, we're here.
Oh.
Which one of us are you asking?
Anybody. Whoever knows the answer.
Well, I mean, it's kind of cheating. Brad already said
right?
It's the angle of the Great Pyramid, yeah. So,
oh, yeah, that's right. Brad already, yeah, okay.
I was trying not to cheat, trying not to be a cheater over
That's
here.
right. Brad stole my thunderstorm generator.
But linking it into the cosmos, right? It's double the great year. Is that right? It's double 25, 9, 20. You go 54, 8, 10. Which way is it, right? He uses
So
it all
half
the
of
time.
that. Yes. And this gets us into, this takes us into some rather esoteric stuff here. And really what this, I think, is leading to is that there are fundamental frequencies embedded in the whole creation of the universe, from the macro to the micro. And this works because it's conforming to those ratios.
Bing, 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 bing. Where's the bell?
That's why the shafts in the Queen's chamber were left closed, because they were like the little diffuser.
Maybe.
The tiny little microscopic bubbles in there.
So you can see here, this is not a trivial operation here. This is, there's some major ability, technological knowledge, and some resources behind this. Let's check this out. So this is going to be, of course, further down the road.
Those look dangerous.
Yeah.
All right.
Yeah, you don't want to sit down abruptly on one of these.
Yeah, don't leave that on your chair. It's
Yeah, don't leave it on your chair. Okay, so here's the generating plant, the power generating plant, and here's another video of the assembly that's going on in the shop. Here's your cross section showing the whole assembly in 2 slides. If you go to look at this, has not been published yet, but it will be soon. Here's a 3D schematic of the thunderstorm generator, and here you can see the inner pipe right here feeding into the swirl chamber, the spherical swirl chamber here. Okay. And this is what's happening. It's a vortex in the bubbles. And this is what's happening in these micro bubbles. As you've got, when they collapse, it sets up this vortex, and you've got to picture that these swirling electrons and ions are going down this vortex, picking up velocity as they're reaching the terminus of the cone here. And then what happens? They meet their opposite at the equator with the so-called 0 point.
Look like the pole of Saturn there, right? That eventually it turns into a hexagon.
Yes. Okay. And that, I wasn't going to mention that, but since you did, Brad, yes, this is a very interesting component of this, which suggests that the hexagon on Saturn is probably plasma.
All right.
All right. So again, more schematics, and this is going to
worth of stuff here.
Pardon me?
You got 2 shows worth of stuff here. How much more you got?
We got to wrap it up here, buddy.
We're pushing.
Let's wrap it. Okay.
Hours. Yeah.
Well, we'll get to the point where they've finished the build.
This is the build for the facility in England.
For the facility in England, yes. There's the 3 plasma generators that are going to be going in. Here is the site itself. That's Gary Ling again, overseeing the delivery. Here are the site managers deciding which generator to retrofit, and they've picked out this one. Let's see. It'll be this one here that they're going to do the retrofit on. So this is the housing around the generator. Here is the delivery of the thunderstorm generator to the site. And here's where it's going. And this is all about calibrations before they start testing. Okay, so here is the thunderstorm generator on the flatbed. And here's the crane about to lift it up in place. You can see it's being emplaced right there. This is just a video of the emplacement. And then you've got the engineers and the technicians who are actually doing the assembly. The team there that's hooking this up to the generator. Down below here, let's see there. I'm going to go through this really quick so that people can see that this really happened. The managers of the site were convinced enough by what they saw to go ahead and allow this. And yeah, here you can see this is feeding up into the thunderstorm generator. It's coming from the 3 bubblers that are, you can see them right down here underneath. and it's feeding up here into the thunderstorm generator and then feeding back into the 400 kilowatt generator. And here they put the heat resistant paint on. So that is probably a good place to terminate for now.
That's awesome, man. That's really cool.
Oh, yeah.
That's great.
Very exciting.
Yes.
And the sucker works, man. And I've now, last weekend, to wrap it up, here's the generator and here's the connections with the generator. So last weekend I was there with a group, included our friend George Howard, and we had people, and we'll introduce some of those people, and what their backgrounds and technical and scientific skills are. But we had 3 different analyzers there, including somebody who brought from one of the top laboratories in the U.S. That he's affiliated with, brought his own mass spectrometer so that he could test it independently. So he was there. I watched him build the thing onto the generator and had the opportunity to flip the switch of the technology and was able to see firsthand exactly what then happened to the exhaust. And once again, our friend George did a repeat performance of plasmoid huffing just to show that this was pure, clean air coming out of the exhaust. And
brave man.
Yeah, brave man. He put his own life on the line to show that. And, you know, George was right from the beginning, he was a skeptic.
Oh, yeah.
Which is good.
Sure.
Yeah.
Because you need to have skeptics when stuff like this, you know.
Totally.
But yeah, so now the London build out has been verified, a verified independent test. A whole different group of people there than you had at the Tesla conference, and another independent group at this other laboratory of one of the top industrial facilities in the country that is doing research into alternative energies. So those are the 3 milestones of the last couple of months. And at this point, you know, I've been, you know, my whole strategy in effect was to be in a holding pattern until we had the tests. I didn't want to come out and say too much, even though, you know, I was confident that there was definitely something here of merit and value and reality. But until we had these 3 independent confirmations by independent groups, I was, like I said, on a holding pattern. But now it's ready to go to the next level.
Yeah, that's great.
So that's, we definitely need to have further conversations about this. There was so much we jumped over, but like Brad said, all of this stuff is being open source. So, and let's see, Alchemical Science, Jordan, I don't know his last name. He's doing a really good series on, because he's attempting to understand the technology. And so Malcolm and several of the other engineers are going to be working with him, and they're going to try the second automobile retrofit on his personal car, which I don't know what it is.
So again, to be clear, because I see lots of people asking questions in the chat, again, to be clear, like what we've been mostly looking at here is a retrofit of engines that use other fuels, like more conventional fuels.
Correct.
You put the retrofit on that engine, and the idea is that it increases the efficiency of the fuel use, the regular fuel use of that engine, plus it minimizes, the output of gases like carbon monoxide,
stuff.
Yes.
things that people call pollutants that get put out.
The hydrocarbons, carbon monoxide, right?
So that's
dioxide also.
There are other possibilities for this technology, but right now we've been mostly looking at the retrofits, but there's other possibilities. But for now, this is about it. Yeah.
Yes. But let me say this. The fossil fuel is only used initially to get operating temperatures necessary to cause the ionization of the molecules on the atomic level. That's the creation of the plasmas. Once that happens, the machines are now being fueled by the plasma. The plasmas take over from the fossil fuel. The fossil fuels are only used initially to get the temperatures hot enough to cause the electrons and the neutrons to disassociate.
Okay.
So that's an important point.
Yeah.
So what that does is it minimally, conservatively doubles the efficiency of the engine, and this is like only in the initial stages. It's actually showing that the potential to increase the efficiency of any engine increases considerably more than 50%.
Right, which means the engine continues to use its regular fuel. It just is using it to maintain the temperature, right? That's the idea.
No,
because if it stops using the fuel, then it would have an infinite efficiency.
Well, at some point it probably runs out, I'm guessing. But once the plasmas take over, it's like the Hilch tube. There's no moving parts. It's all the plasmas themselves that are energized and doing this work.
Okay.
So it gets and listen, I'm still in the grade school level of understanding this.
I don't understand it at all. So
listen, I was there when
exhaust. It's not necessarily running the machine; it's cleaning the exhaust. So it has to keep using in that application. It has to keep using the gas.
That's what I thought. The retrofit, yeah.
It keeps recycling the exhaust.
Okay.
So I know there's going to be a lot of questions. I still have a lot of questions, and I'm hoping that enough people, a lot of smart people, start looking at this. And by comparing notes, we'll all be able to accelerate our learning. That's kind of what I'm interested in. And several of the people, like this fella Jordan, I imagine I'll be reaching out to him because he's really, really going serious about trying to understand it and do it, backyard applications of it. But
he's coming from a mathematical background.
Yes, he was a student of Marco Rodin, I believe, as was Kean, who is the Oxford student that has been assisting Malcolm in developing this. Let's see. Actually, I don't see the posters on HowTube either. Not sure. Maybe they're on randallcarlson.com. I'll find out and make sure we have a link.
Yeah, they're not on the website either.
That was the first check.
Yeah. So we'll get them up there somewhere.
We'll get them up there somewhere.
I think they'd be on the Strike Foundation channel on HowTube, but I can't say.
Well, maybe there'll be a link because I don't think that they've. We did a run of posters because we knew that there would probably be interest. I don't think Strike Foundation has any. Are we at the end?
Okay.
I'm rolling
way past.
Yeah.
Oh, way past the end. Okay.
Well, let me just thank some people here real quick.
Sure.
Viking Gaming, I'm the Cool Man, John Lopez, Mike D, Viking Knows Best, Keaton Allender, John Lopez again, Diamond Lightning, New Phase, Jay, Andy Plays Games, Sanchocho, Bull Bear, Gek812, Dan Coldus, sorry, Dan, Margaret Watson, Xavian. Thank you all so much for donating. Sorry we couldn't get to any of your comments or questions. Randall had a lot of material for this episode, but there will be more.
Yeah, and we do really appreciate the donations because this is helping.
Absolutely.
We're funneling a lot of this to Brad so that he can be supported in the manner to which he has become accustomed.
What?
Hot tubs every night, man.
More. Wait a second.
So in the lifestyle to which he has become habituated, which is traveling and doing research
for these tours. Yeah, so we want to make sure everybody checks out what we're up to. Get Randall out in the field and see him on the trail and up against some huge, awesome looking rocks and erosional features across Washington, Idaho, Oregon. We're going to be getting into Utah. We're talking about more Four Corners trips and doing them over here on the east in the Appalachians, west of the Appalachians on
got 3 spots left in Montana. Coming up in 2 weeks.
Basalt Plateau. That's right.
Only 3?
Not Basalt Plateau. I'm mixing up 2 things. Yeah, we want to wrap up here, so I'm talking too fast. But yeah, there's three spots left for the Montana that's coming up in 3 weeks.
And it's going to be a lot of fun. Everybody has fun. We make new friends. We see old friends, and we see some awesome landscapes and learn one hell of a profound, mind-boggling story in the process.
Eat some great barbecue.
Oh, that sounds good.
Yep. So yeah, we mentioned earlier we got one in Tennessee, Central Tennessee. the Cumberland Plateau there over Halloween. So you got a couple months to get ready for that one. And two coming up next year already. We've started to offer, including a new one into the Columbia Gorge, which was some of the recon I did this spring. So, yeah, excellent stuff. Get out and be seen on the scene with RC.
And understand that when we're not posting regular contents, it's because we get overwhelmed by, we've all been on the road a lot. Russ and Kyle have been busy with their harvesting. But we're going to try to do better. And if we don't, know that it's because we're out doing stuff to help bring in more knowledge, more information, more insight into all of these really interesting things that we like to talk about and study and learn about that we can then share with all of you guys.
That's right. Thank you guys so much. Thanks to the mods in the chat and all of the chat people. Thank you.
Thanks,
See you next time. Yeah.
See you next
Thank
time.
you, everybody.
Good night, Randall. Good night, Brad.
Randall.
Good night.
Good night, Kyle.
Good
Good
to
night, Russ.
see
Good night,
y'all.
Brad.
Good morning over here.